We're taking our fraction 3 over 17. And we're adding the same number to the numerator and the denominator. Do we know what that number is? No, we're going to let x equal a number. It's just some number. So I'm going to add x to the denominator. I'm going to add x to the numerator because it says what number must be added to both the numerator and the denominator. So that number has to be added to both to equal 3/5. So now I cross multiply and I get 5 times the quantity of 3 plus x equals 3 times the quantity of 17 plus x. And if we solve this, we will get x is equal to 18. All right, next one. The average speed of a train was increased 10 miles per hour. The 300-mile trip it takes would require 1 hour less time. Find the new speed. So this is a distance speed problem. So I'm going to make a table. I'm going to have original and increased. And we have our distance, our rate, and the time. So I'm going to let x equal original rate. If the average speed of a train was increased 10 miles per hour, the 300-mile trip. So what is the distance? 300. So this is in miles. So we're 300, 300. We don't know the original rate. We decided to call that x. But for the increased rate, we're taking that original rate x and we're going 10 miles per hour faster. So how am I going to represent that? X plus 10. You got it. And this is miles per hour. And then remember, the time is the distance divided by the rate. So we're 300 over x and then 300 over x plus 10. Okay. If the average speed of the train was increased 10 miles per hour, the 300 miles trip would take 1 hour less time. So we're clearly comparing their times. So we have the original. We have to somehow make it equal the increased time. Oh, not increase time, increased speed. Sorry, increased speed. Okay, so which time is longer? The original time or the increased speed time? The original time is longer, and it differs by how much? 1, right? It differs by 1 hour. So if we want to keep this balanced, right? If we want to keep this equation balanced, we have to add 1 or subtract 1. Since we know the original time is already longer, to make it equal the increased speed, wouldn't I add 1 to this? Or if I wanted to, could I subtract 1 from this? Does it matter? No, I don't like subtracting, so I will add. So I'm going to add 1 to the increased time to make it the increased speed time to make it equal the original speed time. So then we're going to have 300 over x is equal to 300 over x plus 10 plus 1. Everybody okay with how I figured out where to add that 1? Yes. Yeah, we just said that. Okay. It will still work out the same. I just like to add versus subtract. Okay, so right now, can I cross multiply this? No, I can't cross multiply because it's not a proportion. We have that plus one. So what would I have to do here? I don't have to make a common denominator. No. Add. I don't want to add. No. Yeah, eliminate the denominator. We want to eliminate the denominator. And how do we eliminate the denominator? Multiply everything by LCD. And what is the LCD here? X times X plus 10. So here the X's cancel. Here the X plus 10 cancels. So I will bring it up here. So we have 300 times X plus 10 is equal to X times, or 300X, I should say, plus X times the quantity of X plus 10. So I'm going to distribute in this 300. We're going to get 300X plus 3,000 equals 300X plus X squared plus 10X. Do we all agree we're going to have to factor because of that X squared? So I need to set it equal to 0. When I set it equal to 0, I'm going to get X squared. The 300X's cancel out, right? Do you guys see that? So plus 10X minus 3,000 equals 0. So we're going to get an X plus 60 and X minus 50. So X equals negative 60, X equals 50. Can I have a rate of negative 60 miles per hour? We can't. So for that reason, we're rejecting the negative 60. So we're left with X equals 50. Now let's see what we want to find. Find the new speed. Was X the new speed or was it the old speed? It was the old speed. So what is the new speed? 60. So the new speed equals 60 miles per hour. Not so bad, right? Next one. So it says the members of the math team were contributing equally to raise $240 for a trip to Mathland. When 4 members of the club decided to stay home and study for their algebra test, everyone else had to pay $5 more. How many members were on the team? So I'm going to let X equal members. All right, so initially the trip cost $240 and they were going to divide it by the total amount of members. So do we agree to do that? We're going to do 240 divided by X, the total amount of members on the team. But then something happened. Then 4 members decided to back out. So we are now taking that 240 and dividing it not by X anymore, X minus 4, because we're losing 4 members. Now we have to somehow make these two equal each other. Well, what had to happen for that to equal out the price? Everyone else had to pay $5 more. Okay, so now we know we have to add $5 somewhere. Do you agree to keep this balance? Let's think about where we're going to add it. All right, if you take a number, the same number, and divide it by a smaller number, take a number and divide it by a number, and then take that same number and divide it by a smaller number. When you divide by a smaller number, don't you get a bigger quotient? Versus when you divide by the bigger number, you'll get a smaller quotient. So do we agree this side is already bigger? Because we're dividing by a smaller number. So this side is already more money. So to keep it balanced, since that side's more money, it's more money by how much? $5, right? So wouldn't I have to add 5 to this side to make them equal each other? So I'm going to add 5 on this side. Can I cross multiply here? No. What should I do? Eliminate the denominator. And what will I multiply to eliminate the denominator? Multiply by? You got it. X times the quantity of x minus 4 times 5 plus x times the quantity of x minus 4 times 240 over x equals x times the quantity of x minus 4 times 240 over x minus 4. All right, so here's the x's cancel, here the x minus 4's cancel. So I have 5x times the quantity of x minus 4 equals 200, sorry, not equals, plus 240 times the quantity of x minus 4 equals x, or sorry, 240x. So distribute in this 5x. So we get 5x squared minus 20x. Distribute in the 240. And we're going to get 240x minus 960 equals 240x. Do we agree these 240x's both cancel? So we're going to be left with 5x squared minus 20x minus 960. Can I pull out a GCF of 5? Yeah, which makes this problem a lot easier. So now we're x squared minus 4x minus 192 equals 0. So I'm going to bring it up here. So this is going to be an x minus 16 and an x plus 12. 5 can never equal 0, so that's out. And then we'll have x equals 16, x equals negative 12. Can I have negative 12 members? No. So my only number is 16. What does this 16 represent? The original number of members, right? And we want to know how many members were on the team. Does this represent the number of members on the team? Yes. So we're going to have 16 members. Okay, number 4. I'm going to stress this right now, and it will still happen that somebody on the test will set up a system of equations. This whole test will only be in one variable. If you set up a system of equations for any of the problems, I will not give you credit for it. This must be in one variable the whole entire test, no systems of equations. So when it says the sum of two integers is 18, I do not want to see x plus y equals 18. There will not be any systems here. We do not want two equations. So when it says the sum of two integers is 18, to keep this in one variable, I'm going to let x equal the first integer. And if the sum is 18, how would I represent the second integer? You got it. 18 minus x will equal the second integer. Okay, and it says the sum of the two integers is 18, and the sum of their reciprocals is 1/4. Well, what's the reciprocal of x? 1 over x. And what's the reciprocal of 18 minus x? 1 over 18 minus x. And that sum of their reciprocals has to equal 1/4. Would I eliminate the denominator here? Yes. What would I multiply to eliminate this denominator? Yep. If you solve this, we are going to get x equals 6 or 12, which makes sense because it doesn't really matter. if you start off with the first integer as 6, what's the second integer? 12. If you start out with the first integer as 12, what's the second integer? 6. So it doesn't matter. One of the integers is 6, the other one is 12. So first equals 6, second equals 12. It doesn't matter. If you wrote first equals 12, second equals 6, it doesn't matter. We're going to skip number 5. We're going to come back to number 6. Let's do number 7. Okay, so number 7, Maya, hi. All right, so number 7 reads, a boat whose speed in still water is 20 kilometers per hour traveled upriver 24 kilometers to Stillwater Lake, crossed to the other side 5 kilometers away, and then retraced its route back to the starting point. Okay, so what's happening here? We went upriver and then we went across. But then once they got to their destination, they traced their steps back. So then they went across, and then instead of up, they went down. So let's map this out. So we went up and then across, but then didn't we go across again? And then down. So I'm going to let X equal rate of current. Look good. So a boat whose speed in still water is 20 kilometers per hour traveled upriver 24 kilometers. So what is our distance upriver? 24. And then it crossed to the other side 5 kilometers away. So our across is 5. But then didn't we then cross again to go back? So that's 5 again. And then since we're retracing our footsteps, what happens now to go down? How many kilometers is that? 24. Now, when we were going upriver, was the current working with us or against us? Against us. So this is going to be X minus, 24 minus X, not X minus, 24 minus X. When we're going across, 24 plus X, right? We're going slower. No. 24 minus X. Oh, I keep seeing 24. Okay, 20 minus X. Yes, we're going slower. Okay, when we're going across, the current's not going to help us. It's not going to work with us. It's not going to go work against us. It's just our speed, which is 20 and then another 20. But then we're going downriver. Isn't that going to make us go faster? So 20 plus X. And remember, so this is kilometers per hour. And our time is going to be our distance divided by our rate. So we're 24 over 20 minus X, 5 over 20. What's 5 over 20? 1/4. And then 5 over 20 again, which is 1/4. And then 24 over 20 plus X. Now it says if the entire trip took 3 hours. This is where my equation comes in. I'm going to the time, and what do I have to do with all of these times? Add them and set it equal to 3. You got it. So we are 24 over 20 minus X. What's a fourth plus a fourth? A half, right? Are you guys okay if I just write a half instead of 1/4 plus 1/4? Plus 24 over 20 plus X. equals 3. I think we're good at solving these right now, right? If we solve this, it's going to be x is equal to -4 or +4. Can we have a current of -4 kilometers per hour? No, so we'll just have x is equal to 4. Was it asking just for the speed of the current? Yes. So we're going to have 4 kilometers per hour. Okay, let's go back to number 6. All right, number 6 says 2 front end loaders can remove 3/4 of the dirt from an excavation in 1 4/5 days. Working alone, loader A would take 2 days longer than loader B working alone to remove the dirt. How long for A to do the job by itself? So do we agree it's going to be A plus B, but this time doesn't equal a total job? What does it equal? 3/4 of a job, which is fine. So the 2 front end loaders can remove 3/4 of the dirt in 1 4/5 days. I'm going to change this to an improper fraction. So 1 times 5 is 5 plus 4 is 9. So this is 9/5. Where does that 9/5 go in these fractions? In the numerator. So then it says loader A would take 2 days longer than loader B. So I'm going to let X equal loader B time. So if X is loader B, A is 2 days longer than that. So what is that going to be? Or is it A longer or B longer? Sorry. A loader would take 2 days longer. Okay. So then it's going to be X plus 2. Could you have done A as X and then B X minus 2? Would that have been okay? Yeah, it's fine. Okay, now I'm going to show you a couple of things. I can actually here on this left side pull out a GCF of 9/5 because both of their numerators are 9/5. So I can pull, which is going to make this problem look a lot easier, 9/5 times 1 over X plus 2 plus 1 over X equals 3/4. Let's say you didn't recognize that you could pull out that 9/5. Well, do we agree that each of these fractions is, for like the first one, 9/5 divided by X plus 2, which is the same as 9/5 times 1 over X plus 2, which is the same as 9 over 5 times X plus 2. So you could write it that way if you wanted to. But isn't it a lot easier to pull out that 9/5? Because now I can just divide by 9/5 on both sides. So I'm going to have 1 over X plus 2 plus 1 over X is equal to change, flip. So 3/4 times 5/9. I'm going to cross simplify. 3 goes into 3 once. 3 goes into 9 3 times. So I have 1 over X plus 2 plus 1 over X equals 5 over 12. And now, doesn't this look like all the other problems we've been solving? When you solve this, you are going to get X is equal to -6 over 5 or 4. Can we have -6 over 5 as an answer? No. So we just get X is equal to 4. But then I think it was asking loader A. So what's loader A? You got it. 6 what? Is it days? Days. All right, we are done. I can probably give you back your tests now and we can start going over them, the test from Unit 4. So let's do that since we have the time.